Hi friends, today we are going to cover flashback and point in time recovery. So, in this practice we will perform the following: point in time recovery in a pluggable database, PITR on a table space in a PDB, flashback at CDB level, flashback at PDB level. Practice assumption: CDB1 in MRV1 database is up and running. So we have MRV1 server up and running. So we log into PuTTY and bring up the database. We first start the listener. Then we'll log into SQL Plus and bring up the database. Okay, database is started and performing PITR in a pluggable database. In this section of practice, we will perform point in time recovery in PDB2. Firstly, we will perform the PITR in pluggable database level, and secondly in the table space level. We will insert some rows in a table and delete them and recover the PDB to the point before the delete statement was executed. Make sure you have local undo enabled. So SQL plus /sysdba that we have already done. Then we will run this SQL query. So local undo enabled is equal to true. So local undo is enabled. Then we'll connect T user oracle at PDB2. T user is not present, so we may have to create a T user. we are connected. Then we don't have this table, so we'll create a table TB1. So we'll create a table, create TB1 ID table created. So now we'll insert some testing data. So we'll run this. More privileges on tablespace users. Okay, I grant unlimited tablespace to T user. So now I should be fine. Now if I run this code, it should be fine. So PSQL procedure completed successfully. So now I can find out the count on this table. The count is 10. Obtain the current SCN and take note of it. In real life scenario, the recovery point is known by specific time rather than by specific SCN number. You can use the following statement to convert the timestamp into SCN. Select timestamp to SCN from dual. So we connect a sysdba. Sysdba, then we will select the current SCN from the database. So this is the SCN, we'll make a note of it. Okay, we made a note of it. So next, delete the rows in TB1 and comment the deletion. So we'll connect user Oracle PDB2 and then delete from TB1 commit. So we have deleted and committed. Then perform PDB PITR on PDB2. rman run rman. So we'll come out of SQL plus and run rman target We'll close PDB2, alter pluggable database PDB2, close immediate. Okay. Then we will run this command to complete the PITR. We'll run this command to complete the PITR. Run until set until SCN. So we will recover till the SCN that we noted earlier. So we will run. So we'll run this. So finish recovery. So recovery is done. Now we will open it through reset logs. Alter pluggable database, open PDB2, open reset logs. So statement processed. So now we will connect to SQL plus T user PDB2. So exit from RMAN. SQL plus, and then we'll do count of the table. So we can see that the 10 rows are restored. We have deleted the records, but as we did a point in time recovery of the HCN prior to the deletion, so those records are back. Now take a backup of the whole CDB. This is recommended after every PITR process. So after every PITR process, you should take a backup of the whole CDB. So exit unman target slash delete backup set, delete backup set. Yes. Okay. Then we will run this backup command. Backup database plus archive log, delete all input. We have just completed PITR on a whole PDB, where the PDB was brought back to SCN prior to the deletion operation. and we could see that the deleted records are restored back, and we can see those records in the table. The backup is still continuing. Okay, the backup completed. So now performing PITR on a table space in a PDB. In this section of the practice, we will perform PITR in the table space level. This method provides higher availability than PITR at the pluggable database level because other table spaces will still be active while you are recovering the lost table space. However, it involves creating a temporary instance. Therefore, it takes longer time to execute and requires much more disk space than PITR at the PDB level. Verify that the table TB1, which is owned by T user, is saved in user's table space. So we'll log in as SQL plus to T user and to T user. So exit from admin. SQL plus T user Oracle at PDB2. So we'll connect, and then we will run this query. So it is indeed using user's table space. As user's table space is the default table space, you need to switch the default table space of the PDB to some other table space before you proceed with the PITR procedure on it. Create a staging table space and set it as a default table space. So connect /sysdba, connect /sysdba, set container to PDB2, alter session set container PDB2, then specify the default table space is user's table space. If default table space is user, select status, verify if the user's table space is online. So it is online. Then we'll create a table space, create table space staging TBS. Then we will alter database default table space staging TBS. Let's change the default table space. Then take a backup. I'm not going to take a backup right now. Okay, now we will SQL plus to user, then we will delete from T user TB1, format, then we will run this code again. This is the same code. Yeah, the same code, so we'll run it again. And insert another 10 records. And do a count star of TB1, 10. That's Now again we will connect a sysdba and we'll check the current SCN. We note down the current SCN. Then we will switch a log file. Then we will connect to T user. Then we will delete from the table. Make user's table space offline. So we'll connect a sysdba. We'll set the container to PDB2 and then we will alter table space users offline immediate. Okay, we will make the table space offline. Then we will create a directory in which auxiliary files will be created. So we will log into PuTTY, create another session in PuTTY. Make directory. Okay. Then we will log into Arman. Create Arman target slash. To execute this statement on mine, this statement will make Arman create an auxiliary instance from the which user table space we will recover. Make sure the used directory exists. So this is the command. Recover table pair SCN is this SCN. Where put this SCN? So this command will run. So the auxiliary instance, as you can see, the auxiliary instance is started. So this creates an auxiliary instance and then it recovers the table space. No backup or recovery of the control file found to restore. Okay. So anyhow, this failed because there is no backup, but this is the procedure of point in time recovery of a table space. We'll next move on to using flashback in CDB and PDBs. Performing flashback for the CDB from dropping a common user. In this section of practice, we will enable database flashback in CDB1. Then you will use the flashback to recover from dropping a common user. Common users are created in the CDB level. To use the flashback to recover from dropping a common user, you must flashback the entire CDB. So first we create a common user, we log in as SQL plus /sysdba. So we will log in, we exit terminal, we log in as SQL plus /sysdba. Then we'll create a common user, C #user1 identified Oracle. Okay, we already have a user C #user1. So let it be. Make sure the show parameter db plus recovery area is enabled. So we see that the fast recovery area is already enabled, and its value is /u01/app/oracle/fra. So enable flashback of the CDB. It requires CDB restart. DB restart below is not needed. Thanks for someone who pointed that out. Actually, DB restart below is not needed. So verify flashback is off. Select flashback. Flashback on is no. So shutdown immediate. Shutdown immediate. Okay, then startup mount. Then alter system set DB flashback duration target for 1440, scope is equal to 4. Then alter database flashback on. Database alter. Then alter database open. Alter database open. So now we will select the SCN and make a note of it. So this is the SCN. And take a note of it. Okay. Then drop the common user C #user1. So first we will select whether the user exists. The user exists in con ID 1. hash user 1 drop user c hash user 1 cascade user drop. Now I run this query again. There is no row selected, so the user is dropped. So now we'll switch log file multiple times. Okay, multiple times we have switched log files. Now flashback the CDB up to the obtained SCN. Observe that the operation takes less time than PITR. So shut down immediate. Shut down immediate. Okay, startup mount. Then we flashback the database to SCN that we have loaded. So the command is database SCN, SCN is SCN that we have loaded. Okay. Flashback complete. Okay. Open the database in read-only mode and verify that a common user is recovered. Opening the CDB in read-only mode does not automatically open the PDBs. You have to manually open them. So alter database open read-only. Then alter pluggable database all open read-only. Okay. Now you should see the common user. So as you can see, this common user has been restored. So we have successfully done the flashback of the database to the prior SCN. Open the CDB in reset mode. So shut down immediate. Shut down immediate. Then startup mount. Then alter database open reset logs. database open. So database is now open in reset log, open reset. So that's it guys. You can perform PITR on a single PDB, keeping the CDB and other PDBs up and running, while meanwhile it is easier to execute a PITR for a PDB when local undo is enabled than when shared undo is being used. You can perform PITR on a table space within a PDB, keeping the PDB and other table spaces available for users. However, this process involves creating an auxiliary instance, which means longer recovery time and more disk space is needed. Flashback PDB is a more efficient recovery way than PITR. However, it is not practically a full replacement to the PITR. Flashback is best used for recover to a short period of time in the past, where PITR is best used for recover to a long point in time in the past. So that's about PITR and flashback recovery. Thanks friends. Bye.